Our today's speaker is Thorn, who is a data manager at the Museum for Naturkunde Berlin, and the topic is data standards for natural science collections. Caitlin, the floor is yours.
Okay, so welcome everyone. So what we'll go over today is basically what data standards and schemas are, why you should use them, and then we'll do an overview of some of the key standards, including Darwin Core, ABCD, and LIDO. We'll look at how to choose the right one and what resources you can use to get started in using them. So why do standards matter? So there's an explosion of biodiversity and natural science data. In our museum, we're digitizing the collection, and I know a lot of other museums are doing that. So that has dramatically increased how much natural science data is out there, as well as, of course, researchers researching, generating data, publishing data. So there's just a huge amount of data to do with natural science all around. So standards matter because it's important to standardize in research, publishing, and collaboration. Are you familiar with the FAIR principles? So it's kind of principles for open science, publishing data. So it's to do with making data findable, interoperable, reusable, and in particular, standards focus on the interoperability, means that systems can understand data because it follows the same format. So we have some consequences if we don't use standards. The consequences of messy data include misinterpretation, so maybe not being able to read the data properly if someone else is looking at it. Limited reusability, so again, it makes your data a little harder to approach if it's not standardized. And then we have a loss of scientific value. As you can see on this graph on the side, 80% of research data is usually lost after 20 years. So we want to reduce that by having data in formats that are reusable by others, and then we can try and maintain them. So there are also other challenges without standardized data formats, such as the context of the data is lost, there are data silos, it's harder to collaborate, and there are redundant efforts because people are, again, trying to interpret the data. So what is a data standard? A data standard is a set of agreed upon rules, guidelines, and formats for how data is collected, stored, exchanged, and processed. So it specifies the elements that are to be used in particular context across all applications, as well as the structure and the meaning of the elements. So it ensures consistency and interoperability of data across systems, and it facilitates data sharing and integration because it allows systems to speak the same language. So data standards provide consistency in how we record and share information. You've probably already heard of some data standards. I'm not sure how familiar you are with natural history ones, but maybe you've heard of something like the ISO date formats or CSV files are certain standards. So there are a few different parts to data standards. They can also be called metadata standards. They're pretty much the same thing, depends on what data you're looking at, whether it's metadata, just data, which relates to the language and logic used, and it describes the meaning defined by standardization bodies. And then we have the data model, which defines the structure the metadata can have, which is broken down into the data, which are the statements about an object described, and the model, which is the description of how statements are structured. And then we have the syntax, which is used to represent the corresponding statements generated by the data model. So it's a representation format, XML or graphs, and it's represented by constructs of the data model. So the data model is in turn represented by syntactic constructs. That's kind of the technical aspects of what a data standard is. But what is a data schema? A data schema is the blueprint or the structure that specifies how data is organized within a database or a data file. Schemas are like the blueprint for the data. So they define the structure, the elements of data, such as tables, fields, data types, relationships between different elements. They're essential for databases and APIs, really, and they allow semi-automated data check, and the schema conforms to databases in which metadata is recorded and stored. So how do these things work together? Is it a schema or a standard? Schemas often operationalize the standards. So the standard is the guideline, and then the schema is the technical details. For example, both the conceptual standard and the XML schema may share a name, but they're distinct components. One is the guideline and one is the implementation. But because of this, standard and schema are often used interchangeably, even though there are technical differences. They're two different things, but we kind of go back and forth when we use those words because often they're talking about the same end product or the end idea. So what are the differences? Again, to summarize, the standard is the broad guidelines for data management, and the schema is the specific blueprint for data organization. So the standard, the purpose is interoperability and consistency, but the data schema structures and validates the data. The data schema is the more specific, detailed set of rules, and it is things like the XML schema or a JSON schema, whereas the data standards, just kind of the definition of what will go into that schema. So what's the benefit of using standards and schemas? So I talked a little bit about this already, but it helps with interoperability across platforms and makes data easier to share with others and to publish. A lot of publishers require using a data schema, so then you can improve the discoverability of your data by publishing it to different places like GBIF or iDigBio. It also facilitates data quality and validation because you can do a quality control check of the data in a standardized way, and it future-proofs the data for further use. So what are tools for data unification? So today I'm going to talk about basically the ones with stars next to them in a bit more detail, but these are some schemas and standards and other things which aren't quite schemas or standards but come into play with those. We'll start with having a look at ABCD. ABCD stands for Access to Biological Collection Data, and it was developed by TADWIG, which you'll hear a lot, which is the Biodiversity Information Standards Group. So the focus of this is detailed collection data, and it's suitable for museums and herbaria with rich metadata. It's basically a way to catalog or document your objects in the collection, and this is all based on object-oriented data. It also has extensions, so it's not just for biological data, but it has an extension for geosciences, which is ABCDEFG. And for the technical details, it's hierarchical and has an XML schema and supports complex relationships. And it can be important because it can help you integrate your data into external aggregators such as GBIF and GeoCase. And this is kind of an example of some of the fields and what it looks like. So this is the schema kind of documentation, and you can see on the left-hand side all the different elements, or a few of the different elements. There are hundreds, and they kind of outline what fields you need within the schema to refer to different ideas related to the object. So for example, you want to have a contact person, and then you want to have their telephone number. So that is how you would like write that into the XML. Another one that is widely used is Darwin Core. Darwin Core is a kind of widely used metadata standard, and Darwin Core is a play on that, specific to biodiversity data. This is also developed by TADWIG, and it standardizes terms for species, specimens, observations, and samples. So there are various different specialized extensions for it. For example, they have a multimedia extension, and the idea of it is to be like as simple as possible. It emphasizes interoperability by basically just being a lot of terms, like definitions of terms that you can use to present things. There are also community efforts on like developing ways to use those terms, but the Darwin Core itself is just the terms. And again, you can use this for GBIF integration as well as iDigBio. And the last is LIDO, that stands for Lightweight Information Describing Objects, and it's developed by CIDOC, which is ICOM's International Committee for Documentation. And ICOM's is the International Council of Museums. LIDO is not specific to natural history. It's used for any kind of museum, library, or archive, and it goes into like detailed event-based documentation of object histories. So, for example, in natural history, you might have an object that was collected on an expedition by a person in 1853, and you could include all this information about the expedition as well, and how basically the history of the object. So then the object was collected, and then it went to a museum, and then it was transferred to another museum. You could kind of include all this history within the data record. It is an XML schema as well. It's a hierarchical structure. It has a lot of use for provenance, ownership, and context over time. And the important use cases here are if you are in Europe, working for a European institution, you can publish to Europeana using LIDO, as well as DDB, which is the German Digital Library. We can also publish museum data there using LIDO if you're at a German institution. And I'll show you an example of what it can look like. So this is an example of a collection object. Basically, it references a lot of controlled vocabulary through Getty through the thesaurus there. We use different LIDO terms, like we use different classifications to talk about the taxonomy of the object. And then it goes further into ownership of the object, as well as other details later on about how it was collected. So MIDS is another specification. It's not a standard or a schema. It defines how much information you have about a specimen. It describes if your specimen is bare, basic, regular, or extended. And I'll show you an example of this in a minute. But the other one is the Minimaldatensatz. This is specific to Germany. So this is developed by the German Digital Library, and I consulted with them on natural history specifics, making sure it was included. And this is a general thing for all museums, and it has required and recommended fields to include when you're publishing your data. So this is a look at MIDS. If your data was to reach MIDS level 1, it would have to include all of these elements. So the physical specimen ID, the organization, name, specimen type, object type, license, and when it was last modified. We use this at the Naturkunde Museum as a KPI for our data to see how many of our digitized objects reach MIDS level 1 as a measure of how comprehensive our data is. So while this isn't a standard out itself, it helps to have our data standardized so that we can track this in a regular way. This is also like quite relevant to include here. So we'll talk about choosing the right standard. How do we do that? So first you want to look at your data type and the granularity of your data. So how detailed your data is, what you plan on including. And then you want to look at the target audience for your data. So are you trying to publish it to a certain place or get certain people to look at it, and what context would they like it in? And then you want to look at if you need a complex or a simple data standard. If you have more detailed data, you might want a complex standard, but it might be worth keeping a simpler one if your data is quite straightforward. And then you also want to look at the tools and the community support for using each standard. So most standards have communities of people using them. And if you can get in contact with them, I think that's very helpful in actually using a standard and getting familiar with it. If we were to choose standards by data type, for specimen occurrence data, we'd want to use probably Darwin Core or ABCD. This is, of course, not a comprehensive list. I'm sure there are others out there as well, but those two are very common. For multimedia data related to natural history objects, you might want to use Darwin Core, which is another TIDWG standard. For general museum objects, not necessarily natural history data, you might want to look at LIDO or the SciDoc CRM. For ecological research data sets, there's EML, which is ecological metadata language. There are specific standards for molecular data, as well as Darwin Core extensions for them. If you have geospatial data, you want to use ISO standards or GeoJSON schemas, like quite important to look at what your data type is and what is the aim of the specific standards that you're looking at, and see what kind of matches. I'm not against talking to like AI and getting it to suggest to you what to use. I think that's actually quite a useful thing to do if you're trying to pick a standard and you're not quite sure. For example, Darwin Core and ABCD are quite similar, but there are a few differences that are quite specific. So maybe that could help you if you're a bit confused. So where do these standards come from? They're all developed by communities who work with data. A lot of the ones I talked about come from TEDWIG, which is the Biodiversity Information Standards Group. They have a huge community and they are quite a welcoming community. So if you ever want to get involved with their different working groups on the different standards, or if you just want to ask them questions, I would highly suggest like emailing any names you find of people involved with them, and they'd be happy to help you get started with them, I'm sure. Standards are community driven, and it's a community effort to maintain and develop the standards. So how do you start using standards? The first thing you would do is to review your data and then choose the appropriate standard. So like I had in some previous slides, you'd look at different aspects of who's your target audience, what kind of data do you have, what do you want to do with your data. And then I would start with a standards website. Usually they all have websites and they have lots of information on how to get started. And then you can also look for community discussion, things like Slack channels or other forums. We'll probably have examples of people actually using the data, like using the standards with their data. So you can have a look into those or reach out to people yourself. And then you want to map the fields from whatever data you have to the fields of the standard. So you want to see how they kind of fit together and create a mapping. And then you would build the structure of the data, whether that's XML or JSON or something else. And then you want to validate the data, so you can validate the schema with different tools, and then of course publish or share your data. I've got a list of various resources here. So like I said, the TEDWIG website is very helpful. It has information on all their standards, and I'm sure all the other institutions that work with standards have websites and pages about them. So definitely start with those. Yeah, there's different reference guides for different things, schema browsers. One tool for editing data is OpenRefine. So that's, open software, a bit similar to Excel, but with specific data transformation tools. So that can be helpful in preparing your data sets. You can have a look at other example data sets that people have published or discussed. And then I have the BioCase provider service. So that is a system that you have to set up on a server. So if your institution already has it, that's very helpful, but you can use that to map your data to different standards in somewhat of an automated way. That is super helpful if you have access to that. You can use other XML tools like Oxygen XML to also validate your XML data and try and get it in the right format. In summary, your data will benefit from following a standard. You'll have increased collaboration opportunities, greater data visibility, easier integration into research networks because you can publish and share your data, more robust data management practices within an institution. For example, if you standardize the way people publish data within an institution, your data is a lot more interoperable, shareable, findable. So feel free to experiment with what will work best for your data. Have a look into some different standards, play around with them and see what you like. And then also reach out to the communities. They're there to help you. They want you to use their standards. So I would recommend reaching out to people. The use cases are almost the same. ABCD is an actual schema with the XML schema. Darwin Core is a list of terms, but a community has taken those terms and basically developed a standardized schema that everyone uses by default, but it's not actually part of the schema. But there is actually work to somewhat merge these standards and merge the development. So my understanding at the moment is that ABCD is going to be maintained, but not further developed. That is something we dealt with recently because at the MFN we have kind of an internally developed schema called MyPod, and that was for something that was like consulted with all our collections that suited all of them and fit all of them. But we recently decided to use Darwin Core instead of that because of the need to publish our data to different external providers like GBIF. It totally depends what repositories you're publishing to. For example, like GBIF, you can use Darwin Core or ABCD. If you're publishing to Europeana, you have to have LIDO. See where you want to publish, see if they have any specific recommendations. We, of course, have the problem that we want to publish to GBIF and LIDO, so we need both standards. So we just want to make sure that we can convert between the standards easily as well.